Hello and welcome to this screencast on solving Sudoku puzzle using Python. Uh, my name is Pranav. Typically speaking, solving Sudoku using programming traditionally comes under the game theory concept. And one might wonder, why are we talking about game theory in the context of uh, artificial intelligence? Well, let me tell you that game theory is one of the fundamental areas where AI can be typically applied in order to develop a smart solution to deal with the problems that are associated with game theories, right? So here we go. So the Sudoku that we are talking about in this scenario would be a 9 by 9 Sudoku, meaning that there are total 3 by 3 and there are 9 boxes in all, essentially, and each box has 3 by 3 three columns and 3 rows together, right? So each row is represented by alphabet, right? So this is A1, A2, A3, A4, and so on and so forth. So each row here is represented by an alphabet, and each column here is represented by a digit. So one stands for the first column, two, and so on and so forth. So right, this is a matrix of strings, essentially. That's what it is. So in order to solve that, we have to first try and get a feel of how this matrix is actually constructed in the first place to begin with. So let's look at some of the code that has been written. We'll go through it line by line. uh, First, we see here that we have a function called cross, and the description for that would be a cross product of elements in A and B. So cross product doesn't mean that it's A cross B and you're multiplying two matrices. It essentially means that you're combining rows and columns from singular matrices of size 3 by 3 in order to form that 81 big plotted, because that's 9 by 9 and you have 81 squares, 9 rows and 9 columns all together, and you have this big 81 squared matrix in all. Essentially that's what you're trying to build. So here this addition operation A plus B doesn't mean that you are adding two variables. You're actually trying to add two matrices to form a bigger matrix, and that's what it does. So when you run this program, and essentially this just returns the matrix, but I have added changed the code a little bit and added a print statement here. So you can see that when we run this program, actually this actually prints out all the um, combinations of numbers and rows and columns all together. But you can observe that this is a single array that contains all the rows and columns in a single array that's one dimensional, but we don't want that. We want a two-dimensional array that's of size 9 by 9 and that contains a 3 by 3 box grid of numbers. And that's what this code here, again the following code, is going to do. As you know that the rows are labeled A through I and the columns are labeled 1 through 9. That's what we are trying to do. We are building a square. We are building squares of rows and columns, meaning A1, B, A1, A2, A3, so on till A9, B1, B2, B1 till B9. And for that essentially builds your big matrix of A1 through I9. And for that you are trying to build a submatrix of size 3 by 3. That's what you are doing in unit list matrix, and you build that. So when we talk about this, so we have a dictionary that we are going to implement and take only the unique values from the squares and try to build that. And when we come to the test method, we can see that that's what we are trying to accomplish, that there are 81 squares and there are 27 unit lists Why 27 if you ask? So you have 3 by 3 grids and you have 9 of those. So 3 into 9 is 27. You have 3 squares for that. So and you are trying to construct a peer matrix of 20, and this is the layout of what your units and peers data structures might look like. And when you actually print that, you see this ginormous matrix that consists of this following configurations. So in actuality, what you're trying to do is you're trying to build a matrix first off that purely consists of all the matrices that something that look like this but in a single dimension, meaning that a1 through i9 will be in a single dimensional array. Then you try to build something like this by splitting them into boxes and rows and whatnot. So that's what you're trying to do. And when you say a row, it means that this is a row, right? C1 C2, this is a row. Similarly, this is a column. So that's what fundamentally. And when we talk about rows and columns, this 3 by 3 grid that's inside this big 3 by 3 grid of 81 squares, this is called a box, right? So that's the terminology and all the um, programming aspect that there is to this problem. And by the way, this problem was actually solved by Dr. Peter Novak. He is an artificial intelligence researcher and is an author of a textbook called Introduction to Artificial Intelligence by Russell and Novak. So that's about it for this video. Thank you.